Hello, and welcome to our video about our project, titled Effects of Environment Stress Factors on LEGO Performance. My name is Abby Sickelsteel, and my partners for this project were Michael Metzing and Jessica Hausnecht. In this video, we will talk about how we addressed each required aspect of the project as it pertains to chapters 2, 3, 6, and 7. Then we will discuss our results from the project. In regards to the human system, our project is primarily focused on the sensory and visual system. It focuses on the visual system in a sense where the tasks of following the instructions involves identifying fine pieces and correctly assembling them. It focuses on the sensory system in a sense where the examinee can audibly hear any noise or distractions during the assembly, as well as hear the clicks when pieces are put in place. Also, when the examinee touches the pieces when picking up and arranging the parts in the assembly. Now we will talk about the types of charts we have created for this project.
This is a fault tree diagram. At the top level, we have defined our unfavorable result of the study as a long completion time by a participant to build a LEGO assembly. Each of the blue symbols is an OR logic gate, indicating that at least one element of the level below contributed to the elements above the gate. We believe that a long completion time could have been due to at least one of several factors, such as difficulty with instructions, the level of experience of the observer, and the distractions to the user during the time study. As an example for the level of instructions, participants complained that the instructions had fuzzy pictures, and we noticed that some people misread instructions. The OR logic gate shows that sometimes one or both were issues with regards to instructions contributing to long completion time.
We created a multiple activity chart. This chart is operating on the basis that it takes about 7 minutes for the examinee to assemble the LEGO car. There were two different paths for the observer. They either had to observe at the end of every minute, or they were able to rest the entire time with no observation. The examinee is assembling the LEGO car for each option.
We also created a precedence diagram to talk about what needed to be done to create the LEGO car. This should have been the same order, regardless of which instructions were used, although some of the participants attempted to complete the assembly in the wrong order, usually causing a delay in completing the assembly.
For this study, we looked at the effect of different distractions and stress factors on someone's ability to quickly and accurately build a LEGO car assembly. The three distractions or stress factors that we looked at for this time study are observation, time constraint with a countdown, and the rigor of the instructions provided. For observation, one of us left the corner of the room or table and checked up on the participant about every minute. For the time constraint, we told the participant that they had 7 minutes to build the LEGO assembly and had a clock that counted down from 7 minutes sitting right in front of them. Finally, we controlled the rigor of instructions by removing steps from the original set of instructions to use on the test group.
For this time study, we started the clock when the participant flipped over the instructions, and we stopped the clock when the participant put the final piece in place, and everything else was correctly finished, meaning that every piece was in the place that it was supposed to be.
Now we will discuss the results.
The effect summary tells us that none of the main effects of observing, time constraint, and instructions are significant. None of their interactions are significant either. It could be argued that the interaction between time constraint and observation was almost significant at an alpha equal to 0.10, since the p-value of 0.11141 was just above that. This might make sense given that being observed and having a time constraint, which are two stress factors, would affect the performance of an individual who has greater test anxiety. However, in isolation, people who are not bothered by either might explain why the main effects, that is, observing and time constraint individually, did not show significance. We looked at time versus college class as well. Classes 1 through 4 indicate freshman through senior respectively, and 5 indicates anyone beyond an undergraduate senior. We only had 2 participants in the last group, a professor and grad student. The data appeared to meet the assumptions of normality and homoscedasticity, so we did an ANOVA and found that class was not a significant predictor for time with a p-value of 0.1671. But the ordered differences report showed that the greatest differences between classes were between group 5 and the rest of the undergraduate groups. We also did a 2 to the 4 full factorial analysis of observing, time constraint, instructions, and class. None of the main effects or interactions were significant. The three-way interaction between observing, time constraint, and class were closest to being significant at a p-value of 0.13982. This may relate to what we saw on the previous slide, where the interaction between observing and time constraint were closest to being significant.
We found the most statistically significant data when looking at the experience level and gender. Experience level showed that learning curve could have been a considered factor within our experiment. The interaction between the two also showed that females were more impacted by experience level than men were.
Thank you for watching.